guys, this is displacement lesson part 2. If you have not already watched part 1 with the water activity, please make sure you do that. The book uses this scenario, putting a solid into a container of some sort and the water actually overflowing. We did a slightly different take on that. Instead of the water overflowing, imagine it all sort of floated up to the top. Of course, that's not how it actually works. That exact water ends up on the top. But if we could find the amount that either overflows or ends up on the top, that slice of water on the top, that's the object's displacement. Okay, if you didn't catch this from the video, volume of an irregularly shaped object is still area of the base, but this is of the container. So whether you have a cylinder, that's what we used in the video with a cup, or a rectangular prism, we're talking about area of the base. It's not of your object, it's of the container. Then times the change in height of the water level. So that's called delta H. That's the change in height of your water. Okay, so let's go through a couple examples here together. Example A, if you need to pause and write part of this down, you can. When you put a rock into a container of water, it raises the water level 3 centimeters. I'm going to pause right here. That is delta H. Okay. If the container is a rectangular prism whose base is 15 by 15, what is the volume of the rock? Notice they don't tell us the height of the container, but we don't care. We really just care about the change in height of the water level. So our formula, volume equals area of the base times the change in height. This capital B, like it has for so many different lessons now, gets its own little formula. That's base area. We have just a 15 by 15 square on the bottom, and then times the change in height of 3 centimeters. So imagine we drop the rock in, the water that the rock displaces floats up to the top. Okay, imagine you could freeze it and just pull that little slice out of there. It would be also in the shape of that rectangular prism, 15 by 15 by 3. So the volume of that water is 675 cubic centimeters, but that is also the volume of this irregularly shaped rock for which we don't have a formula. Okay. Let's take it one step further here. And this, I think you also have done in chemistry. We're going to talk just briefly about density. Okay, so we know, here's our definition, the mass of matter in a given volume. So the piece that's really important for us is we need to either find, or maybe we have that volume, and we'll find some other missing pieces. Okay, so we're going to use this formula, density equals mass divided by volume. You might be familiar with this version. If you just multiply both sides by V, you would get mass equals density times volume. You're welcome to use that one as well if you'd like. Okay, so for this example, there's sort of a lot going on here initially, but this chart that's here you'll be using in later practice problems. Okay, we'll reference that again later. So we've got a clump of metal with mass, as part of our formula, 351.4 grams, is dropped into a cylindrical container, causing the water level to rise 1.1 centimeters. I'm going to mark this right now. There's our delta H. I guess we could mark this as well. There's our little m for mass. The radius of the base of the container is 3 centimeters. What is the density of the metal? And then, this I think is pretty cool. If you know the density, you can determine what type of metal that is as well. So we're going to start, we sort of have two parts here. And eventually we'll use this formula, but if you think about all of these pieces, we don't know the density. Obviously, we're looking for that. We have the mass. We don't know the volume. We need to calculate that on our own first. So we're going to find V first, the volume. Now this is a displacement problem. We don't know what this clump of metal looks like, or we don't have a formula for it anyways. So we're going to use this formula, area of the base of the container times the change in height of the water level. It's a cylinder. I underlined that up there. It's a cylindrical container. So for base area, we want pi r squared. They do tell us the radius is 3. And then the water level goes up by 1.1 centimeters. Okay, so that volume is approximately 31.1 cubic centimeters. Okay, so we know that part. Now we can use that to find the density. The density is mass divided by volume. We have a mass given to us of 351.4 grams divided by 31.1 cubic centimeters. That's about 11.3. You can see how the density is listed here. I don't know if you remember this from chemistry. You can also see where that unit comes from. Grams per cubic centimeter. So how many grams are stuffed into each cubic centimeter. Okay, so there's the density, and then from our chart, here we go, 11.3, that must have been lead. Okay, so tomorrow, make sure you have good notes on this. Tomorrow, keep those handy. I'll bring this chart back up. We'll do some more practice problems with displacement, volume of irregularly shaped object, and density. Okay, have a good one, guys.